Your multimeter. This we're going to go over a panel, what a panel does. There's sub panels and there's main panels. This panel had another box above it, and it had a meter, or a place for a meter. That would be to measure our electrical current flow. This is like a typical sub panel, which means that you would have this for a back house or a barn or something like that. Typically your two hots would come in here. Notice how on this hot, if I put it on ohms, which looks like a horseshoe, and I go like this, OL means open. This means that there's so much resistance. There's basically, if I push real hard, there's a few ohms of resistance just through the wires. Resistance is opposition to flow, current flow. So here, this is hot. This one goes here. This one's connected over here. Every other one is connected. This is your hot, they call this a bus. This is your hot bus. This is for one hot leg, and this is for the other hot leg. So if you had 120 here and 120 here, it's 240. So once again, this is where your hot wire would come in from either the bottom if you have an underground feed, or the top if you have a top overhead feed. It has continuity because it's beeping. Then if I go over here, it's beeping. You may not be able to hear it, but it's beeping. And then not this one, but the other one would also have it. So what happens is you have to have the right breaker. There's fuses. Fuses come in the round screw-in fuse. You have car fuses that look like, I can open this here. This is a fuse. Do you see the little teeny squiggly thing? Almost looks like a light. What it does is that's a resistor, or it's a squiggly line that slows down the flow and only lets so much flow go through it. It's rated by voltage, and it's rated by amperage. Almost everything is rated by voltage, which is pressure, amperage, which is rate of flow, okay? This is your current common breaker. This is made by Square D, that's a manufacturer, and basically what happens is these breakers fit in. They have a place there that goes in and over here, so it fits in and pushes in. Now it's in. So now what happens is the power goes through the wire, through here, and when this is on, let's see here, make sure this is on. There should be flow here. That's not working. Let's see what the problem was. It was stabbed in. Maybe this breaker doesn't work. So if you wanted to check a breaker, you would put your meter here, and then you would go ahead and put your meter over here where the outgoing wire goes to protect the circuit. And guess what? This breaker is no good. See, I get no continuity. If I go this way, it beeps. I can hear it beep. It's pretty quiet, but I can hear it beep. So what that means is this breaker is broken inside. That was a 20 amp breaker, but this is a 20 amp. But this allows you to do is it has two outgoing wires. So let's see if this one will work. Just because it fits, you don't want to use it because it could be just a teeny bit of a gap which would create arcing. But once again, this has, there's all different types of breakers. The breakers protect the equipment. They protect the equipment, the wires, the switches, and also in case of a ground fault, they will trip. We'll put this one here where this part stabs into here and this goes here. So they have overcurrent protection. Here if it goes like 28 amps, if it's 22, 23 amps, it will basically cook this breaker, but it may not trip. But if it gets much more than that, it will trip, which will go ahead and it gives you an overcurrent protection, meaning that you're using like 25, 28, 29 amps, 30 amps, 40 amps, has overcurrent protection, and ground fault, which means if you have an inrush straight to ground. So let's see what we have here. First, you always test your meter to make sure your meter's working. Okay, this one's beeping. It says there's 1 ohm between the wires. 1 ohm resistance. Resistance is the opposition to current flow. Okay, this one's working. I can hear it beeping. This one works. Now, so what would happen is this would go here, and click in here, and you always put them in on the off and then you turn it on. So now we should have conductivity or continuity. which between the hot wire and also here. And you can hear now it is beeping, which means that this breaker is ready to feed and protect whatever it needs to protect down the line. And then if we had another one, we would put another one, if this one were working, we would put it in here, okay? And this one here is just broken because I can't get it to reset. But basically, this is how breakers would go. So this right here would go to this hot. This one here goes to this hot. If I had another one here, it would go to this hot. Every other one equals this. So if you had two wires coming out of here, you can get what they call a 240 breaker and put a 240 breaker here. The reason why you want 240 together is if something happens, you have, by code says they have to be tied together so that when one hot leg trips, the other one will trip with it. So that you won't think it's off when it's really just one hot leg is open or shorted or whatever. Okay? So you have to tie them together. But this is basically how it works. Now what this stuff for us here is this is for your neutrals, which is your return. And then you would have your wire going from here to a ground rod in the ground. And these are for your grounds. Here's your ground wire right here. Okay? And this is for your neutral wires right here. If you notice, there's no continuity between these two. And the reason being is if this is a 120 and this is 120 and there was continuity, then what would happen is I'd have a direct short between two hot legs and it would blow up as soon as I turned on the power. There's no continuity between here and either one of these because once again, this is a neutral and it's going to be grounded. These right here are for your equipment grounds. These have continuity to your panel. Right now I'm hearing a beeping noise. That means that this is connected to here. It has continuity. Okay? These are for your neutrals right here. Okay? Or your return. If we imagine that this is our silver bus that we called, one of them, you know, the one that has a lug. Okay? And then it has those little things that go like this. And we imagine that there's a breaker here. This is a breaker. A breaker protects the wire going out. It protects the switch. It will help protect the load or the toaster. And then what will happen is the power will come back on a white or gray wire. The power will come back to the panel and to the neutral or return where it's connected to a ground rod for 0. So this is hot, 120. And the only reason why it goes through this is this has a load. Basically, you may remember if you look inside, it has these wires that glow inside the toaster. So what happens is this slows down the flow. If you can imagine if you had to run up and down hill, it slows you down. If water had to go up and down instead of straight, this slows it down. If you went ahead and you took this hot wire here and you touched it straight to here, you would have a dead short. You would have a short and it would spark. But it would not spark for even a quarter second because this breaker would trip. Okay? So that means it's a ground fault protection because it protects it from ground. The other thing a breaker does, it does this overcurrent protection. So in other words, if this toaster were pulling, if this is say a 20 amp breaker, and this toaster was pulling, say, 40 amps or 30 amps, it would also heat up and it would trip, which means it just shuts off, it opens. Okay? So what you can pretend is you can pretend a breaker basically is allowing two things to touch, and then if it gets too hot, it pulls apart. Or if it has too much inrush of current because it dead shorts. In other words, all of a sudden it's like all the gates of water open, okay? In this case, it's not water, it's actually electricity, so it pops open, okay? So this is for overcurrent protection and for ground fault protection. That's what they do. You can also, the old days, the reason why people like breakers is this fuse. When it blows, I got to throw it away because it breaks this little filament inside. They have screw-in fuses, which the same thing happens. Typically, once they blow, you have to throw them away and get new ones. But a breaker, the beauty of these breakers is you can reset them off and on. It resets so you can use them again. Okay? There's different makers. This one's by GE, and it's a 20 amp. This is where the hot goes of the bus. And this is where the wire goes. The wire goes in here. You unscrew this and you just slide the bare tip of the wire in here. So there's all sorts of switches. This is a switch. This is for your ground wire. What that does is that protects, there's continuity between here and here and here and here. This protects the body of the switch. This is what you call your equipment ground. If any of these wires inside here touch the shell, this will make it grounded, which means that instead of when you touch this, you will not get shocked. This will hopefully cause the breaker to trip. Your hot wires go here, okay? One side is a wire feeding in and one side is a wire feeding out. This is not your common outlet, it's a duplex, but it has this line going out. It allows you to use it for 15 or 20 amps. 15 amps is the most common, which would be 2 straight lines. The side line, or the side part of the T, is allow you for a 20 amp plug. The electrical code says that all 20 amps have to look a certain way, all 15 amps have to look a certain way, all 30 amps, and so forth. They're helping protect you so you don't use the wrong device at the wrong voltage. This is the where the neutral wire goes. It has these two adjoining because you have one outlet here and one outlet here, and it's allowing one wire to work for the top and the bottom duplex. Here is where your hot wire goes, and it's the same. These plugs no longer act as one plug, they act as 2 plugs. They break this so that you'll have one bottom is switched by a light switch, maybe say here on a wall, and the other one is hot all the time. So they break it so you can have 2 different feeds on these outlets. Once again, this is a duplex 20 amp plug. It can also be a 15, and that's how you do it. The code talks about this screw has to be a 632. You cannot use drywall screws. It has to be threaded. Everything is a certain size and a certain rating. Over here we have other duplex outlets, but they can come square. Sometimes for a clock on a wall you'll see just a single, but this is pretty common except for the fact that this is 20 amps for your home. Okay? Once again, your ground wire will go on the green or bare screw, which protects the equipment. Grounding, how you realize grounding in the code, grounding has 2 G's, G-R-O-U-N-D-I-N-G, grounding. Grounding is either the green wire or the bare wire in electrical. Green wire or the bare copper wire, okay? They do, in some systems in the 70s, they experimented with some aluminum wiring. And aluminum wiring they found to get hot and actually cause fires. So they don't have that so much in houses anymore, and they actually have to put a certain kind of grease on there, electrical grease, to help keep it when you put a copper wire to aluminum wire, because 2 different dissimilar metals will eat each other. And they will create corrosion, which will create heat. And the heat is also a resistance to current flow. The more resistance, the more heat, and it kind of builds up and it can cause a fire. But once again, this is 15 amp, 120, 277, which is pretty common for outlets, switches, and so forth. If you look on this one, there's a black part on this flashlight battery. That's an insulator. That does not allow flow. This little tit part here, the silver part, goes to one edge of the filament, and then the other one goes to the shell. So basically on any light bulb, if you take a meter on continuity, which checks flow, and you go ahead, and I'm going to use my stomach here, and I touch the tit and the shell, I have continuity. And I also have 1 ohms of resistance. That means that this will shine. This will work.